The 12-factor app is a recommendation for writing backend services for any programming language. So, as they say here, any programming language, but it's easier in some languages than others, and I think it's way easier in Rust than in most. And they wrote down a list of things they learned over the years when writing their backends. And yeah, this is the list, and so the page is 12factor.net, and then you can click on every single point and then get some long documentation about what this actually means, because this is just like a single word. This talk now is about writing a Rust backend service using these concepts, but not all of them, because not all of them apply. But I'm going to go through every single step on the list and explain what this means in the context of Rust. So first off, the first one is code base. One code base tracked in revision control, many deploys. This is easy to do in Rust, because you can have multiple crates in a single Git repository. If you really have different separate crates, use workspaces. I won't go over this today, but workspaces are pretty common anyways. Also, you can have multiple binaries in a single Rust crate, which is also nice to use for this. So next one is dependencies. Explicitly declare and isolate dependencies. That's Cargo does that for free, so we are already set there. Configuration, store config in the environment. This is very different to how I learned how to do this. So this is one of the major points of my coding presentation afterwards. How to do this. So this means that don't use a configuration file, use environment variables. I will explain the reasons for this as well. Maybe I can explain it right now. Might be better. Hold on. So. Okay. So. Let's move it here. So, okay. This is the Docker setup for home automation at Metalab. So there's some services running here in Docker containers. And this is just a Portainer. This is like a web service for managing Docker. Most people use Docker Compose. I don't like it because it's like configuration files. Here it's all graphical. And it's way better for presentation, so I can show you here what I mean. And if you look at something random here, Nginx, for example, if you create a configuration for a Docker container, first off, you have the name here and stuff like that, the image. It's not an important point, but here you have the environment variables. And this means that you can write here in the web interface, configure your own service if you do it via environment variables. You don't have to like SSH into your server and change the configuration file or stuff like that. You can just do it here in the web interface. It's very convenient. Also, if you use Docker Compose, you have all of them in the configuration file for Docker Compose, and don't have to ship another configuration file for this. Or, for example, if you need to set something up here per node, or if you have multiple installations, then it might differ per node, and then you can change it here easily. But for local development, it's easier to have a configuration file. That's why I do both. So like if there's an environment variable set, then I use this. If not, then look at the configuration file. And also, before all of this, there's the command line flags. If you can also set it there. That's the basic idea behind that. Next is backing services. That doesn't really have anything to do with my talk today. That's like if you use a database or some other service, don't hard code the paths in there or passwords or something. Put them into something that can be configured, like environment variables or configuration file if it doesn't work through environment variables. And treat them as attached resources just means that you can switch around the URL, for example, and then it connects to a different service. And it's not hard coded in. Build, release, run, strictly separate build and run stages is easy in Rust. That's for free. This is important for scripting languages like PHP, where running and where you run the source code, which is completely different than in Rust, where you compile the source code and then have a binary you can run. So, but this also means that the deployed container should not contain the source code for your service because it's just a binary. Yeah. Processes. Execute the app as one or more stateless processes. Also easy to do in Rust. The stateless is not so obvious. So if you have any state, use an external service like a database. Don't store it locally. Like, for example, don't embed SQLite and then use that as a database, have some external service that can do that. The reason for this is that if you want to do clustering, like have multiple machines serving the same service, then you can't use local state because every request might go to a different node in your cluster. Port binding, export services via port binding is also basically for free. So it means that, yeah, HTTP is bound to a port. So this is mostly about web services, of course. Could be any TCP service. Just bind it to a port. With Docker, this is quite easy, and you can expose this port. Then I will show that later. Concurrency, scale out via process model, which means that allow for multiple instances of your application to run at the same time. For example, the clustering I mentioned earlier. Yeah, this is also, Docker helps a lot there because when you have one Docker container or Docker image, you can deploy it on multiple Docker runtimes or container runtimes. Next is disposability. Fast startup is for free in Rust because Rust applications don't take a lot of time starting up unless you write it this way. So don't do that. Graceful shutdown means that like don't leave behind any resources when your application is terminated. Not so complicated in Rust. Also means that if you have temporary files, then put them on a RAM disk somewhere, don't throw them on the file system. Then dev production parity. This is more DevOps thing. So use like something like GitHub Actions, GitLab Actions, and let them deploy your application to your server, and then you can just select which server to deploy on, the test server, or the production server, or whatever you call them, development server. So this is a DevOps thing. It's out of scope today, but also if you're working at a company that does services, you need somebody who can do all of this DevOps things. That's quite important, and you only realize it once you have somebody who can do that, because that person is then responsible for like writing GitHub Actions and stuff like that. It's a world on its own. Next thing is logs. Treat logs as event streams. With Docker, this is quite easy to do. You just have to log into standard out, and then I can show you. For example, if you look at the Nginx, here in Portainer you have the logs line, logs link, and then you can see here the log directly in the web interface. You don't need to like connect to your server and look in SSH some file that gets gigabytes in size. Everything is just logged into standard out, and you can see it right in the web interface. This is not an ad for Portainer. You can do the same thing with other Docker systems as well. But this means logging is just to standard out. There are many options in Rust for logging. You can, for example, log to syslog or log to some static file with like rolling versions and stuff like that, but you don't need all of that. Just log to standard out and let the system handle the rest. And admin processes, that means if you need some kind of config, like for example, if you had a user management thing, creating, deleting users, if you want to do that from an admin interface, just create another binary inside your create, and then you can execute this binary. So this Rust also, Cargo also makes this easy by allowing multiple binaries inside a single create. And you can reuse the data structures and stuff like that for communication. But the how you do the communication is up to you. Usually it's just HTTP or something, but that's not really handled by Rust in any way. Okay, so that's the basic idea behind 12-factor app. I don't think it's so complicated. It's 12 things, but most of them are obvious, I think, and many of them are, once you realize what they can do for you, then it's quite easy to adhere to these recommendations. So next step is now the showing you how to write a simple service in Rust. So first off, I'm going to start from scratch here. So really from scratch. So cargo new migrate service. Great code name. So okay, we don't need you. So this is the regular hello world, and I'm going to make it a little bit bigger. Is that okay? Okay, good. First off, we don't need that one. First we're going to add all the dependencies we want. Usually you don't do it this way because you just add them once you use them, but since I already programmed all of the application, I know what I need. Okay, so we have first off we need YAML. Yeah, I think it's the right line. Yeah, there's one missing. Log. So, okay, explanation. YAML for the configuration file. So this is, we're still using a configuration file just because it's easier for local development. And YAML is kind of the best way to do that. We could also use TOML, but YAML is more standardized. And you have to keep in mind TOML is more a Rust thing. I don't know if anybody else uses TOML. And if you write a service like that, then this is going to be configured by the DevOps guy, not by you. So the DevOps guy or girl needs to understand how to write this configuration file. So YAML everybody knows in this space at least. Then JSON we need just for testing, not really necessary. Anyhow, for error management, just because we don't care that much about errors here. Log and log4rs are the logging system. So log is just the facade, is usually the object-oriented term for this. This is like just an interface for logging, but how the log is actually generated and written somewhere, standard out in this case, is done by log4rs. And Exom because we want to write an HTTP service, and there are two major frameworks right now, Exom and ActiveWeb. Doesn't really matter which one you want to use. I just used Exom here because that's what I used for my last project. I tried both and they're pretty much identical from the feature set. Okay. Takes a bit. Okay. And then we need some more. Clap. So I need some feature flags for the next ones. That's why I have them separate. So clap is for command line parsing. We need derive and env. Env is for reading environment variables. So you could do this manually, or you could use clap for this, which does like 50% of the work for you. And derive is using macros for declaring your command line API, which is much easier than doing it via code. So next is 30. Yeah, that's just for serialization. Not that exciting. And Tokyo. Tokyo is for event management, network access, and stuff like that. Usually you don't need to include it explicitly, but for this application we need it. Okay, and that's it. That's all dependencies. So next up, this is going to be async. So we need to make it Tokyo main. Anyhow, result, and we don't have return anything. So okay, yeah, that's not very exciting. So that's the basic thing. We need async because all of the Exum network code is asynchronous. But next is the command line parsing. Yeah. 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 So the reason is that XM uses network access, and network access is bound to the executor. So some crates are independent of that, but those are just things that don't do any file access, network access, or stuff like that. But that's not the case for XM. So XM could implement multiple run executors, but I don't think they do. And everybody uses Tokyo these days, anyways, for like server stuff. If you have embedded, then it's different, of course, or WebAssembly. Okay, next is the yep. So this is the clap configuration. So who knows how to use clap here? Hands up. Okay, 2. Okay, great. Or 1.5. Okay, so the idea behind clap is that start from the basics. If you run your application, you want stuff like dash dash help to show you the help, which of course doesn't work right now. Let's compile it first. So it doesn't do anything because we didn't tell Rust to do anything with dash dash help. So clap handles all of that for us. Yeah, like this. And if we do that, we now have a help message. Help message already contains like the name of the service, help itself, of course. Doesn't do anything else right now because we didn't tell it to do anything else. What it can also do is like add some copyright message or who wrote this thing, using some annotations here with your struct, but I don't care about that right now. So we now have basic command line handling without doing anything. So we don't have any command line flags, but help works. So that's great. So next up is let's start with the logging. Yeah. So that's the most important thing if you start developing anything, any application. First start with logging because then you can log your stuff and you get like errors back and things like that. Don't start with like println and then replace everything with log later on. That's not useful. Just start with logging and then you can log all the time during development. But so we want to use log4rs, but this needs a configuration. Log4rs has a mechanism built in for parsing a configuration file for logging, which we could use, but the problem with this is that's just a configuration file just for logging. So you would need 2 if you want to add your own configuration stuff, which is not useful. But I found a different way to just embed their configuration into my own configuration file. And I'm going to show you how this works. So first, we need to know where to get the configuration, and this is a command line parameter, like config, not string. String would also work, but path is better, because then clap already makes sure that this can be parsed into a path path, which doesn't make much difference on Linux, but on Windows, for example, if you have illegal characters in there and stuff like that, then it can handle that. And you need to tell clap, yeah, stuff like this, short. We want to have C as short. So dash C is the same as dash dash config in this case. So config is the name we're using here. So it knows to use this one for the long version. I can show you in the help. So now we have this line here. We can also specify a default. Config.yaml sounds like a good default. Now we know where to find our configuration. What we can also do is env, which means now you can also pass in the configuration, the name of the configuration file as an environment variable. That's all you have to do for the environment variables. Clap does everything for you. That's with the feature flag env. So for clap we have env here. That's why I can do that. It's not included by default. Instead of this, you can rename it here. Oops, like this. Then it's my config. Yeah, usually you want to have this a bit more unique, but in this case, since we're using Docker, it's like a whole operating system just for this one binary. So we won't have any conflict with anything else because there is nothing else on the system. Okay, so let's load this configuration file. Let's start with the configuration file parser. So new file, config.rs, which a pro tip for Rust, always if you create a new file, use mod, do the mod line first, because then you get like inline error messages and stuff in there already. Otherwise, as long as you don't include it anywhere, then it won't try to compile it. So you won't see any errors. So. Okay, we want some config. This is serializable, deserializable. Yep, like this. And debug. Always use debug. Even if you never use it, just for logging and stuff like that, if you need to debug it, it's always easier. And we need to include not this one. We need to include the configuration for the logging here. So that's pop logging. And that's log for rs config raw config. That's already deserializable, which means all of there's a whole tree in there for the configuration, and we just include it like this. Don't have to care about the specific syntax or anything. It's Serde does everything for us here. And then, not default, just import config. You need a parser for this. And this one has a file name. For people new to Rust, this is how you can pass in a file name where the call has multiple options on how to handle this. Because a path implements sref path. You can pass in a path, you can pass in a path, you can pass in a reference to one of these and stuff like that. So this is more flexible. It's not more complicated to use, and so it's the best solution because the caller decides which exact type to use. Okay. YAML. So this is a YAML file, so you use YAML from slice. Read and so yeah. Okay, let's do this later. Use the path. I'm using the read from Tokyo, so this is asynchronous. Not really necessary here because we're blocking until we have the whole configuration file anyways, but doesn't hurt to use use it either. So we need the standard path and we need a Tokyo FS read. And this is asynchronous, of course. Yeah. So now we have the parser, that's it. We don't need more than for the parser. If we want more configuration stuff, which will happen later, we can just add it here, and it's going to be included in the syntax for in the parser for the configuration file. Okay, let's create the configuration file now. But for this, I'm just going to copy paste it. It's not really. I'm not going to explain everything in the. Okay, so that's the wrong indent, I think. Yeah, great. Yeah. Okay. Yeah. So easy fix. So logging is the thing I defined here. That's this one here. So everything below logging is the standard configuration format of log4s. Log4s has multiple configuration things. You can like log into files and standard out, for example, log to a network service or something like that. You can define the format. For example, in this case, we're using JSON as the logging format. So it outputs JSON to standard out. If I don't want that, and I don't want that right now, I can just comment it out. That's the advantage of using JSON for configuration. JSON does not allow comments. YAML does, so that's much better. A kind console just means to log to standard out. And in the root, you define which ones of these appenders here you want to use. We defined one that is called standard out, and we just tell it, yeah, use this one right now. So you can have multiple here, multiple appenders here, like network appender, file appender, rolling file appender, and so on, and then just enable and disable them here as you need. And here's also the log level. So you have debug, you have trace, debug, info, warning, error. I think that's it. And you can set the level. You can also here set the level per module in Rust. So if you have a larger service and you only want the detailed logging for one module and not for everything else, then you can configure that here in the configuration file. You don't have to change your code for this. Highly recommend it. Okay, so but that's the most basic thing we can do, and it's good enough for this presentation. Now we want to pass this configuration file. That's, yeah, exactly this. So now we have a configuration file here. And now we need to tell the logger that we have which config to use. With the init raw config, call config.logging, not unwrap, use. In this case, it would be the same thing, basically, but yeah, error handling. So now we have logging. Now I can use log debug, hello world, and we get hello world as the log output here, including a timestamp and everything else. You can configure this format in the configuration file now, in the config YAML. But this is the default, and this is good enough for us. You can also do stuff like colored logging and so on, so that error logging is red and things like that. Okay. Next is Exom. For Exom is the HTTP service. First, we need to open a listener for this listener for TCP connections. So we need to know which IP address to listen on and which port to listen on, which is also can be a command line parameter or in the configuration file. And if it's a command line parameter, it also can be an environment variable at the same time because clap. So that's what we do now. Yeah, that's listen. It's an option because if it's not available, then use the one from the configuration file. L. I think it uses this first letter anyways if you don't specify it. Long and env. Okay, I'm using a socket address here because then clap already makes sure that this is something that can be passed into an IP address and a port. So it does everything for us for error handling here. And we also need this in the configuration file. But I'm using a subsection here just because there's going to be more stuff here, not in this presentation, but in general. It's called server, it has a listen port, yeah, like this. And then we need to include it here. And of course, importing, always important. So, that could be it, but I ran into problems there parsing the socket address. So 30 doesn't know how to do that. So it doesn't really work this way. So you have to do it manually, which is also easy to do. Okay. So that's a manual parser for 30. So now we get a deserializer in and want to return a socket address, option socket address. But we know it's a string, so we can just pass it on here to the string deserialize. And then we try to pass the string into a socket address. And that's not the right way. So s dot to no. What? Okay. Yeah. Okay. To socket address. Then we need to map the error. That's not so exciting. Yeah. That's why it didn't work. Yeah, we need to import the trait for this. And this trait as well. And there's a colon missing here. Okay, now it's done. So now we need to tell 30 to use this function instead of the standard behavior. Like this. Now we have a proper parser for IP addresses and ports. So everything is in one here, so the port is separated by the colon from the IP address. Okay. That's it for the configuration file. Now we need to get this address, because now we have three sources of this IP address and port. We need to decide which one to use, and also it's convenient to have a fallback, a default port on localhost if nothing is specified anywhere, just for testing. So first, try the command line flag, which is also environment flag. If that's not available, then try the configuration file. And if that's not available, use a default. Unfortunately, I couldn't find any like localhost constant or something. I had to write my own. I had to define the localhost myself, which is very weird to define, but whatever. So it's I've used IPv6, which is not that easy to write. Port 8080 because that's usually the default, and the other ones we don't use. So what did go wrong here? Right. Forgot something. So IPv6 header new, and then this one. So like this. So not so great to write, but yeah, it's one place that's not so beautiful. Whatever. Now we have our socket to listen on, and we need the listener. Like this. Yes. So now, not new net. Okay. So now we have our listener, which is like the thing clients connect to, which we can then use later on. But first we need to define which services we have. So services like an URL. We're just going to have one for testing, which is hello. And this is served by a function, because we need to import get and router, probably. Yeah. Okay, hello is not defined right now, of course. Going to do, no, let's do it now. So all handlers in Exum are asynchronous. Yeah, okay. Let's do this one first. First off, always a good idea to log the thing you're listening on. Like this, because if you do something wrong and it's like the wrong port or something, you try to connect, it doesn't work, and you're debugging there for half an hour until you realize that this is like a basic mistake. So always log out the thing you're listening on. So just to make sure that you actually know how to talk to your own service. And then serve. We need two things here. We need the service, that's app, and we need the listener, which is listener. So yeah, for testing, I want this hello route needs to log out the IP address of the thing that's connecting, that's requesting hello. So that's why I used I'm supplying the socket address of the client into the service into the route, which works like this in connect info. Works like this in Exum. It's a bit weird, but yeah, it works. Good. Okay. So it looks like this. So I need to add the socket address here, which means that in my service called hello, my handler, I get the request, and I need to return something from this HTTP request, which is a JSON value. That's why I need certain JSON, and also need to import and the request. That's the some HTTP request, I think. Okay, so first off, I'm going to return something here. That's just for testing. Hello world, like this. I need to import it, of course. So, okay, it's not very exciting. Oh yeah, that's the future. We need to await it. Okay, now I'm going to extract the IP address. Or maybe let's start with running this thing. Like this. Right, the configuration file needs a server. So this is not optional. just have something there. Okay, so it's listening on localhost now instead of the zero everything. A zero everything means to listen on all interfaces, but we're only listening on localhost right now. So nobody at Metalab here can talk to this service, just to make sure. And 80/hello. And we get hello world back. Maybe include the headers. So now our service already works, but we don't see that something happened here. So in the log file is empty, which is not great. Maybe if you're really in production, you want to have it this way, but we're not in production right now. We want to test things, so we're going to log this. And for testing, we also need to we want to log the IP address of the client. So let's get the IP address. Like this. Yeah. So we have the connection info. Now let's get the IP address. And now we have an IP address here, and we can log it. Not like this. This has to be debugged because you don't want to log in production. In production, you use like info or maybe even warning level. So we only want this in debug level, which is for development. Okay, don't forget to restart this thing. Now when we request it here, we can see request from localhost 127.0.0.1. And our service already works, but we're not done yet, of course, because now we just have a basic service. But if you give this to our DevOps person, then they won't be happy because they don't know how to use it. They don't know how to build it because they've never seen Rust maybe. And then they either spend like a week of work looking into how to build Rust and stuff like that, or you supply them a Docker file, and the Docker file describes how to build this and get a Docker image out of it. So that's like a lot of resources saved there. So how to do a Docker file is quite easy. Create a new file, Docker file. But there are multiple ways to build things in Docker. So that the most basic thing you can see a lot is like you create an image based on some Linux distribution, like Alpine or Ubuntu or something. Then you copy in your source code, then you build your source code and run the thing there, which is not what we talked about in the beginning of this talk. So don't do that, because in Rust you only want the binary in the final image, not the source code. But Docker supports multi-stage builds, which means you can say, take this image, build the code using this image, take another image, copy the binary over to the new image, and then use this one for the final deployment. This also works. I'm using this, but the problem with this is every time you build your Docker container, it's going to rebuild all of your dependencies because you have like a fresh system installation you're building in. So that's not great. So every time you change something, you build your Docker file, it takes like, in this case, it's of course a few seconds, but if you have a larger service, that might take like 20 minutes. So that's not great. So somebody developed a solution for this. And it's a cargo extension. It's called Cargo Chef. Yep, Cargo Chef. We can remove this one for now. So, this one allows you to make a 3-stage Docker build. First stage is building dependencies. Second stage is building your own service, and third stage is building the deployment image. Which means if your dependencies don't change, they don't have this step doesn't have to be redone. So Cargo Chef is only for Docker builds. It's not something you use in your everyday life. So it's specifically for building Docker containers. You can install it using cargo install cargo chef, but we don't really need that because there are Docker images that already contain this one by the original developer. And just going to copy the code in here and explain what it does. So that's the Docker container, Docker file. So Docker syntax, I think, is also easy to read if you don't know how to do that at all. So yeah, these are comments. Then first line has to be from. That's the image we're going to use. That's the look mathwalker / cargo - chef. There's a Docker hub where you can look this up. This is this one. Documentation is not so great. But this is basically just the build system as a Docker container. And we're going to rename it because it's so long. Worked here doesn't really matter, somewhere in this image. So this is not on your system, this is in the Docker image. Then we say we want this chef as a first image. Copy dot means copy the local directory on your host system into this image in the work directory, so in /app. So this one copies your source code into there. So everything including cargo, DOML, and so on, and the config file, which you probably don't need there. And then this command tells Cargo Chef to look at the dependency tree and generate a JSON out of this dependency tree. So this dependency tree lists like everything you use and everything these dependencies use, including the version and stuff like that, which allows it to determine if there was some change there. So if you change some dependency, then this JSON will look different. Then it knows to recompile your dependencies. Then you need the second image, that's for the builder. Then you tell it, yeah, copy this JSON file that was generated in the planner into the local builder image. Now tell Cargo Chef to cook, which means building the dependencies, and only the dependencies, not your own source code. And then we're copying the source code into our image, and then we're building our own image, our own application. And here you have to specify the binary you want to build. In this case, it would be the default, so it's not really necessary, but doesn't hurt anyways. And this is the last image. This is the image that's going to be deployed to the server. So this should be as small as possible. So in this case, we're using Alpine Linux. This is like a very small Linux distribution that doesn't ship with anything, basically. But Rust is completely self-contained. Rust binaries, you don't need anything on the system except the glibc. And so this thing doesn't contain much of anything, which is nice because, for example, if you run Python or something, you need the Python runtime, you need system binaries, you need like standard bash stuff and so on. You don't need anything of that for Rust, unless you actually call it yourself, but you're on your own. So same working directory, we're copying from the builder the target release as just the binary to user local bin, and the config file. We need the config file here. And then entry point is the definition what should be executed on the system when it's started. Which means that user local bin migrate service is the binary we want to execute, and we also need to pass in the config. In this case, we wouldn't actually need that because it's the default flag, but it doesn't hurt because then you can have multiple configurations and just switch it here. Also, maybe not bad to point out. Let's see if we can make it work. So if you want to create a new service, you can change the command, the entry point here. You can change it when you deploy the container. For example, you can pass in different command line flags or something like that. It's not so convenient because it's just a long line of configuration things. So it's better if you do it via environment variables because that's like an easy list, an easy to read list. But it's also possible to change this entry point while deploying your container. Okay, so that's the Docker. So I'm not, no, yeah. It's latest. So on Docker Hub, you can actually look it up. Let's put it down here. Yeah. So in Cargo Chef, the tags you can use specific tags here. So you can define the distribution you want to use, like Debian, Buster. You can also specify the version of Rust to use. So I'm usually using latest, but here like 167 Rust compiler. But if you use latest, I think they're building automatically. So like this container was built 9 hours ago. This is pretty recent. And so they're using a latest compiler for this usually, but you can define a specific version if you want. Okay. And now I want to build this thing. Yeah. So this command docker build x build. So build x is like the new build system, whatever. Then the path to build, which is dot because it's the current directory, and then I want to name it because otherwise it's going to get some hash value, which I can use it, but it's not so easy to use. So now it's downloading all of the things, which it's downloading all the things, which takes a while. It's only doing this when there was some change there. So I did this download yesterday and some images have changed, so it's downloading them. Yeah, now it's executing this. So it's going into the app directory, copying files over and building, but it's not done with the dependencies yet, so it takes a bit. Yeah, who has worked with Docker here? Hands up. Okay, and half. Yeah, it's not really necessary for like user side applications. This is mostly for services and backends. Okay, now it's building the dependencies. This is only done once if you don't change your dependencies, which is nice. Okay. Yeah, some unused use. Yeah, whatever. Okay, now I have my image. Docker image ls. So here's a new image that's called migrate service with tag latest, which is the default. Has 11.4 megabytes. That's basically the Rust binary. It's not stripped because Rust doesn't strip by default for some reason. So it could be made a bit smaller, but it doesn't really matter here. So if you want to run this, this is the command to use. Can I scroll this down? No, I can't. Okay, so first off, you have to specify the port to forward into the host system. So this is 8080. You can specify the port on the host system and the port on the Docker container. And this is the same right now. That's why I have 8080 twice here, but it doesn't have to be the same. Then I have to specify a name for this container, which is migrate service, and then the image to use, which is also migrate service right now. Uh, okay. Yeah. 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 I have to stop my service here because otherwise I can't listen on it. Okay. Hold on. E- It is twice here. Dash dash. Okay. Dash is dash dash name, not T. T is for tag. Yeah. Okay. So now it's running through Docker. And 8080. Oops. Okay, that's not so exciting. Ah, right. Yes. So this is the 404 page. Hello. Yep. Hello world works inside the Docker container, and you can. So Docker works like this. You have a registry like the Docker Hub I showed earlier, where you can upload images to. So if you're if you're doing open source, you can just push to Docker Hub and be done. If you're like in a company and have a private service that you don't want anybody else to use, then you have to use your own registry somehow. I'm not going to go into this here, but this is something for the DevOps people to handle. So it just tell, yeah, yep, I can show you. One thing is Control C doesn't work here for some reason, so I have to stop the Docker container. It's like container. Yeah, I can show the containers here. It was container, no Docker stop, migrate service. Takes a bit. Yeah, one thing I ran into with this is that you accumulating a lot of images. So it's good. So if I build it again now, it's done. Yep. So so the dependencies are not built now, only my own binary. Yes. The hmm, I don't think we're using IO util. Just remove this one. Let's build it again. Now it's building the dependencies. Yeah, it can't build single dependencies. So it's either just your service or everything. I think it actually looks at the dependencies, not just a TOML file. So if you add something on top here, for example, it won't rebuild those. Yes. So only when the dependencies change, it will rebuild. Okay. Huh? I did not look into this, so might be possible, but I don't know. But yeah, that would be a good idea. If there's one dependency you change all the time, then it might be good to separate this out. Okay, so now I showed you very complex commands to run here, and you can scribble them down on a post-it and stick it on your monitor. Not great. So that's why there's one more thing I'm going to show, which is cargo make. So cargo make is also again, let's just hide this here. A crates on crates.io. Um, is a task runner. It can do much more than I'm going to show here, but it's basically something like a script system, but more complex with like dependency checking and integration with cargo and stuff like that. And the nice thing about it is you define a makefile, TOML. It's a TOML system, and then you can just throw in all of your commands. It's called tasks here. So I have a build task, I have a run task, I have a stop task, I have a clean task, and a prune. Prune just removes everything. So there's nothing Docker afterwards. And so I'm tell it what command to run. It's always Docker in this case, and then the arguments like build x build, what you saw earlier. And this means that I still have my shell here, so I can do cargo make build, and then it's going to run the complex command. This TOML file also helps as a documentation to remind you, like if you look at the same thing 1 year later, you can't remember how to build this thing, then it tells you how to do it. Also, you just have to do cargo make build and it builds everything. What? Yes, it's a plugin for cargo, so that's why it's not cargo dash make here, but cargo space make. And it integrates with cargo as well. It can also integrate with workspaces. So you can tell it to run this task on all your sub projects. Yes. So the host system needs all of the build system. It needs cargo make. I'm not sure if it needs cargo chef. I don't think so. And it needs Docker, of course, for development as well. Yeah, you want the Rust anyways for the IDE you need the Rust analyzer things, and so you need Rust anyway. So there are ways to around that with Visual Studio Code, like running a remote session and stuff like that, but it's not really useful for example, if you want to um, do like a central server that has all of these things and the people just use dump terminals, then you can do that like via web browser, stuff like that, with like a Chromebook. But it's one way to do it, but don't recommend it because it's way more unreliable in my experience than just running it locally. Okay, so but that's it for the presentation. So any questions? Yeah. Yeah. Mm-hmm. Mm-hmm. Yeah. So the 12 factor is a recommendation. It's not strict. But um, if you need some local state, then you need some local state, and WebSockets don't work with that local state in some way. So on AWS, there's a solution for them where they translate WebSockets into HTTP requests, and they hold the state like the open socket and stuff like that on the bridge server. So like the one that's actually listening on this port, the clients connect to. What I would recommend if you need WebSockets is that the client automatically reconnects properly when the service goes down. So if you restart your service, then the clients shouldn't error out. They should reconnect and restore the state in some way, which is dependent on the application. So there's no general rule how to do this. And also make sure that you're not reconnecting all the time, because then you will DDoS your own server. And so like there's a technique with the fall off. So reconnect after 1 second. If that doesn't work, reconnect after 2, and after 4, after 8, and so on. So the clients don't try to swamp the server with connect requests if the WebSocket isn't open. Other questions? Okay, then yeah. Yes. Yes. So unwrap or else takes a closure. So this is only executed if the other one is an error or none in this case. So this is ignored when this is a sum and not none. With unwrap or this is not a closure. This is some expression. So this is always executed even when the other one is sum. So the difference here is that in this case I could do both probably, but this is a constant here. So it's not doing anything at runtime, which means I can use unwrap or here because there's like no code behind this. Unwrap or unwrap or default is the same thing as unwrap or, but takes a parameter here, and that's the type. That's the thing that's returned when the thing here is none. Yeah. So that's like deferred execution here. In Swift, the language can do that automatically. In Rust, it's not possible, so you have to specify this as the user. Any other questions? Yep. Oh, Exum. Exum. So the one I used here, the Actix. Actix is older, but Exum is more embedded into the Rust ecosystem, so it uses more crates that everybody uses anyways, like request and stuff like that. So that's why it's preferred right now. But both are, from the functionality point of view, they're the same basically. So it took me a long time to find out what the actual difference is. So I asked the Exum developer about this, and he told me to just look it up. I couldn't find anything, so I didn't use it. But after asking a few people, somebody told me, yeah, Exum uses the Rust ecosystem in a better way. That's the basic difference. No experience with OpenTelemetry. Yeah. Yeah, so there's a lot of integrations with Exum and different, also like Sentry integration and stuff like that. Yeah. Yeah, so tracing is basically a replacement for log, but they're somehow integrated with each other. But you can use both in the same project as well. So it's uh, so yeah, it's all connected. You had a question? Well, for unit testing, that's integrated into Rust. So yeah, so to be honest, there are certainly a lot of test systems like test HTTP clients and stuff like that. I don't have personal experience with those, so I don't know which ones to use. But there are HTTP clients for testing, for automated testing, which is probably a good idea for writing services like this. But it's like way out of scope here. Yep. Cargo make is it's installed on the local system, and then it's just a makefile.toml file in the root directory. No, it's a separate file here. Yep. Yeah, I did not explain that. So the anyhow crate, um, I'm using it here. So this is like error handling if you don't care about errors. So you can, anything that implements error can be converted into an anyhow error. And this means you can use the question mark operators here, the try operators is the official name, here and here and so on, even though those are completely different errors. And it just converts all of them into anyhow error. And then you can use debug output on those, so the debug trait, but not much else. So it's good for logging out errors, But if you want to handle errors differently, you can't use this. There's a crate called this error that handles that. So with this error, you can specify all of the errors that can happen here, and then you can do like a match on all of them and handle them differently, but not with anyhow. Anyhow is just error logging, and that's it. Any other questions? Yep. Mm-hmm. So the general recommendation is to use anyhow for binaries and this error for libraries. Um, the reason is that libraries should return distinct errors so that the caller can handle them properly. But in applications, if you don't care about the error, about the specific error, then you can just log it out and terminate whatever you're doing. Yep. Well, handling, are you handling different errors differently? That's the question. You can say if there's an error, do this. That works with anyhow, but not if like connection timeout, do this. If connection closed unexpectedly, do this. If uh, what else is there? Like resource limit exceeded, do this and stuff like that. The different kinds of errors you can't handle with anyhow because anyhow only knows about anyhow error and not all of the other variations. So it basically just converts them into a debug string. But still, you can differentiate between it works and it doesn't work and handle it. In my case, I just return whatever happens. So yeah, here just unwrap even. Because in this case I know that this won't return a none because I specified here that it shouldn't return a none. So I can unwrap here, but if I have an error here, I could also handle this through anyhow. But anyhow is not compatible with exom, so you would have to convert it to an exom error first, which is not that complicated, but not necessary for this example. Yeah. Hmm. Yeah. So yeah. Yeah, Exum has a lot of stuff built in, or some things are just feature flags, not included by default. But yeah, testing is something you very commonly have to do, so it makes sense that it's integrated into Exum. Anything else? Okay, then thank you, and we can into break now.